let's do it. Okay, so as an intro to trig, essentially the goal of this unit is going to be you getting a little bit of information and using what math you know to get a piece of information that you are looking for. And all of that is going to involve angles in the form of triangles, rectangles, whatever, and of course, parallel lines. The main focus isn't parallel lines, but this is where essentially grade 9s and 10s sort of start. And some of you might be coming in again with COVID math, so this might be unfamiliar. I am going to go through it relatively quickly. You don't have to know the math, but I hope that you might have a highlighter or some kind of pencil that you can work through this with, okay? There are some words that you may or may not be familiar with. The first word is complementary angles. Now, to this day, I haven't memorized complementary to be 90. But complementary means two angles, this angle, and you know what? How about I use it as a thicker line? Complementary angles are when two angles, when you put them right next to each other, add to 90 degrees. That's it. So if I say two angles are complementary, even if I don't draw anything, you know they add to 90. That's it. Supplementary angles, I think you can guess. Supplementary angles are angles that will together add to 180. So this angle plus that angle plus that angle. Three of them together, they add to 180. If I had to write it out, I could say something like angle ABD. So angle ABD plus angle DBC, angle DBC will equal to 90 degrees. That's all I'm saying. Right? For this one, angle ABC, angle, yep, go for it. ABC, angle CBD, CBD, plus angle DBE, DBE equals 180. And just things like that. So I'm pretty sure you can follow through. Another relationship. If you have two lines crossing each other, the opposite angles are always equal. What do I mean? Well, how about I do highlighted this time? Ooh, too big. What I mean is this angle and this angle are identical. So if that's 100, that's 100. If that's a 5,000, that's a 5,000. Of course, that's not the case, but you know what I mean. And in the same way, these two angles are also going to be equal. With me so far? So some people are like, yeah, that's obvious, but I have to establish that fact so that you feel confident when you say it. It's not a guessing game, it's truth. It's a theory, it's truth, okay? Any questions so far before I move on? No, going once, going twice? All right. The next three are under the umbrella called parallel line theorem. Okay? We can't necessarily prove it, but it happens every single time. And so we can conjecture and therefore we can indirectly prove. I'm not going to go into the definition of theorem, but here we go. Do you see this letter Z? With me? Yeah. The interior angles, the corners of that letter Z will have equal angles. So this angle and that angle are equal. Maybe that's a little bit tough to see, so I will do this instead. This angle right here and this angle right here within the Z, they are equal to each other. Now, how could I argue and try to show you that this is true? It's probably easier to argue that this is true if I start with PLTF. PLTF, look for the letter F, please. Do you see that angle? Do you see that F? Corresponding angles. In other words, the angles that match are also equal. So this angle right here underneath the F, and this angle right here underneath the other, I guess, little middle line of F, the horizontal line of F, those two angles are equal. And this is my argument. You may not be interested, but again, it's important for you to be able to go from one angle to the other. Clearing this, would you agree if I zoom in here? I'm going to zoom in for a little bit. Okay. And this is the argument. And you might say this is not math, but it is math. Okay. Pretend this is a picture. Okay, it's an abstract picture. Okay, I took a camera, I took a picture, and I put it on a museum wall. Okay, see this part right here within this rectangle. I take another picture right there, and I put that in the museum wall. What would you think? What would you say about these two pictures? Would you say that they are the same, or would you say that they are completely different? No, it's not a trick question. Let's pretend I snapped it perfectly in the center. What do you say about those two rectangles? Same? Sure. Why is it the same? Well, let's put it this way. This line, I said that it was parallel to this line. So these two lines are essentially equal to each other, but different parts of this world, right? They're just different areas, but they're exactly the same. This line is a single line. So this line crossing with this and this line crossing with this, they're going to cross in the exact same manner. With that as an argument, if that's the same, the top right angle of this intersection and the top right angle of this intersection, you can argue, dude, that's exactly the same. You can also argue then the bottom portion of this picture and the bottom portion of this picture should be exactly the same. And then this side right here, oops, this side right here should be exactly the same as this side right here. But what else did you notice about the colors? I made these two colors exactly the same. Why? What did we just talk about with opposite angles? Look at the top right on your corner, on your sheet. OAT. If they are opposite, they are also equal. And lastly, this angle and that angle are going to be equal. So anytime you have parallel lines, all of this suddenly come into play. And again, just like everything else, the more you practice, the more you will see it. Okay? I don't want to spend too much more time on it. So, and there it is. Lastly, before we move on, the very last one, PLTC, I'm going to erase this portion and I'm going to erase that portion. What can you tell me about the blue angle and the red angle? What number do they add to? Somebody, think about it. Maybe I jumped the gun. What angle is a straight line? Oh, isn't that it? If it's a 90 degree, in other words, if it's part of a rectangle, you know that this is 90. If I have another rectangle, that would be a 90. So in total, if I drew a floor here, what is the entire angle adding up to? Every straight line, it actually is 180 degrees. And that sort of makes sense. If I have a circle, to go from here all the way to here, that's 108 degrees. And from here, I turn one more time, that's 180 degrees. Together, you have 360. So it all sort of comes together in a sense of geometry. I see that if we're having some difficulty remembering about 90 degrees, 180, 360, maybe it's better that we do move into triangles first. We can always revisit parallel lines once we get there. So would you turn the page? Let's move on to today's lesson. What I want to make sure you have before leaving today is the tools to do this last page as homework. Yep. It's super important that you have this down because unfortunately, I don't like saying this, but I do keep on saying it. Trigonometry was one of the units. So this thing that we're doing right now was one of the units from grade 10 academic. And so it's an expectation that you already know, and I would have spent like 30 minutes reviewing it. However, because we're in a very special circumstance coming back from COVID, I'm going to assume the majority of you have forgotten. All right? Like, oh, okay. All right. Everyone, you with me? I'm going to ask you a series of questions, and I'm going to give you two choices. You have 50-50 chance of getting it right in your head or verbally. I'd like you to take a guess and see if you can follow through with my chain of thought. All right, I will use red. I will choose highlighter. Okay, do you see this rectangle? Yes or no? Sorry. Do you see this triangle? Yes or no? Yes. Do you see that it is a 90 degree? Yes or no? Okay. Do you see that this bottom portion is labeled base? Yes. And do you see this bottom is also labeled base? Okay. So we started off with a 90-degree triangle and a base. Do you also see one of the corners is labeled by a funky symbol? The same angle here is labeled by a funky symbol. Do you know what that symbol is? I heard a whisper. Yeah, this thing is called, if you didn't know, it's a Greek letter in the alphabet. It's a Greek alphabet letter. Just like how we have ABCs. In the Greek alphabet, I am not a pro. It starts with alpha, and then it moves on to beta. And then the next letter isn't C. I actually don't remember what the next letter is. Is it gamma? Is it delta? I forget. But anyways, our D, I would imagine, is their delta. Our E would be their epsilon. Okay, there's a lot of different letters, but for them, for us, we have a TH sound, right? To make the sound th. For them, they have a single letter to pronounce the letter th. And that letter is theta. Okay? Instead of X and Y, when it comes to angles in geometry, they use the letter theta. Surprise. So don't think it's anything special. It's just another variable, okay? Think of it as X. It's not a big deal. So far, so good? And here is the next thing I want to remind you or let you know. What do you notice? So this is not a yes or no question. What do you notice about the base on the left triangle and the base on the right triangle? What do you notice? The difference. It's not a trick question. Yep. It's longer. Yep. So the base increased. I'm going to write larger. Okay. What do you notice about the angle then? When that base got larger, the angle got smaller. But on the flip side, let's call this an angle alpha. Let's keep it, consistent with the Greek letters. What do you notice about this angle? If that angle got smaller, what do you notice about the angle alpha? It got bigger, okay? So when the far side of that alpha got larger, this angle also got larger. But the angle on the same area as the base, it got smaller, right? There is a relationship. How close of a relationship? We can actually use what I'm going to call an algorithm, a function, to figure out exactly what distance, what length these dimensions are just from the base. And if I have the dimensions of the base, I can figure out what the angles are as well. There is a relationship with both. I'm going to show you how, but to do so, I need everyone to take out their calculators. If you don't have your scientific calculator right now, you can always take out your phone for the moment. You need, if you want to find some success in this unit, you have to find a calculator, not a phone, a calculator that has the function sine, cosine, and tangent on it. So check your phone, or sorry, check your calculator to see if you see these buttons. Okay. Look for the button that says, it looks like sin, but it's not sin, okay? The math has not done any evil or wrong, okay? It's sine, cos, and tangent. Sine, cosine, tangent. Leanne, did you find it? Yes. Sage, do you have it? Zach, does your calculator have it? Yes. Micah, have it? Alan, everyone has it? Well, once you find your calculator. Brendan, got it? Everyone's got it? Okay. This thing is going to be, in my opinion, if this is the first time you're seeing this, it's going to be pretty mind-boggling, okay? The theory behind sine, cosine, and tangent, it brings us back to the idea of a circle. It brings us back to relationships with radius and moving around and angles and all that kind of stuff. But we're actually going to look at the benefits of sine, cosine, and tangent and how we can use it first before we learn where it's coming from, okay? Please repeat after me. Sine. Sine. Opposite over hypotenuse. Okay. Cosine. Adjacent over hypotenuse. Tangent. Opposite over adjacent. Okay, you'll never have to say that again. Here's why. Mathematicians are, yes. So we have a shortcut. Sine starts with the letter S. The fraction opposite over hypotenuse starts with the letters O over H. Put that in order, you get S, OH. Right? So, cosine starts with the letter C. And the fraction adjacent over hypotenuse starts with the letters A and H. And if you say that in the order that I'm showing you with the arrow, it's C, A, H. And lastly, tangent starts with the letter T. The opposite over adjacent fraction is O with A. And if I say it in the order that I showed the arrow, it's T, T, O, A. Hence the mnemonic SOHCAHTOA. Now, not to sound rude or anything, but to me it helped. It actually helped that my high school math teacher in grade 10 had the heaviest Chinese accent in the world. So when he said it, it actually did sound like he was speaking a different language. Not to be racist or anything, but it actually stuck. It actually helped me stick into my head. I don't know what will help you stick that in your head, but that is something that's going to be helpful for the rest of this semester. So, or possibly for the rest of your life if you decide to go in a certain direction like that. SOHCAHTOA. Remember it, right? SOHCAHTOA. Because I'm going to ask you, hey, how do we set up these numbers? Here we go. So you might be asking now, what the heck is opposite? What the heck is hypotenuse? What the heck is adjacent? You see O or A or H being used somewhere. So what the heck are those numbers? Come down to the next bit and I'll show you. Every question will have an angle that you're interested in. For example, please take a look at the left angle. In this question, I am interested in this corner. Make sense? The theta is there, so I'm going to focus on that. Based on this, we can set up our three numbers. All right, where's the 90 degree? Top, bottom left, or bottom right? Bottom left. It's this part right here. That's the 90. The side furthest away from that 90 degrees, if you remember your elementary and middle school, is always called? The longest side is the hypotenuse. Yeah. So goal number one, find the 90 and label the far side hypotenuse. Nicole, with me? Okay. Can you do that with me? Label H. Next, find your theta or find the angle you want. That's right here. The furthest side of that is called, you got two choices, opposite side or next door neighbor side. Opposite. And the last side you haven't talked about yet is the adjacent side. And I think that makes sense. If this is the angle that I'm interested in, which side is next to that blue, or that theta? This side, right? So we call it adjacent. I'm going to give you exactly 30 seconds. Following this, can you label opposite, adjacent, and hypotenuse for the next one? Start with the 90 degrees, move on from there. And time to check. My square is right here, which represents 90 degrees. Is that a hand volunteering, Cameron, or is it just stretching? All right. So this square is 90 degrees, which means the furthest side from that is your hypotenuse. Give yourself an imaginary pat on the back. My angle this time is up here. I am interested in that top angle. The furthest side from that angle is my opposite. And the leftover piece is your adjacent. All right, next triangle, you have 15 seconds, go. And okay. Again, starting with the 90 degrees. Find it. If you found the 90 degrees, then the furthest side away is what we call the hypotenuse. And it might ring a bell if you remember stuff like, Pythagorean theorem, which is now called right angle side length relation theorem or something. It's just something weird like that. It's because Pythagoras wasn't the first person to discover it. He actually wasn't. And so I guess there's this movement of, not putting white European men on a pedestal or something. I don't know, some kind of movement. I don't even know. I just know that the name's trying to be changed. I don't know. It's confusing to me, but maybe there's a reason for it, and maybe I should value it more. I'm just more interested in the math. Anyways, my angle, furthest away, and opposite. The last piece that we never talked about is your adjacent. And that sort of makes sense because, again, that side is right next to the angle. At this point in time, yes. Correct. Yeah, that's another way you can do it. So if you want to memorize something, sure. This is the angle that I'm interested in. Here's the 90 degrees. A is in between. Right? That's a good one. I like it. Okay. If you want to do SOHCAHTOA, you have to be able to do O, A, and H. If you can't label that, we can't move forward because we're going to be using O, A, and H in SOHCAHTOA. All right, here we go. Moving down. Here's your practice. I want you to be able to match the correct sides with the ratio. So take a look, everyone. Step number 1. Do you see how in the first column we are using corner A? Does everyone see it? Nicole up here. Do you see how it's all A? Alex, do you see it's A? Cameron, come on, do you see it's A? All right. That means my angle for these three is this corner. Right? Does it make logical sense? I'm not doing any math yet, right? What is the opposite side if A is my angle of interest? What is my opposite side? What is my hypotenuse? Using pencil, I'd like you to label it, please. Here's my 90 degrees. Here's the angle of interest. So you could think of that angle A as theta. What is my opposite, adjacent, and hypotenuse? Yep. Top? What is top? Okay, so you know what? This is a good opportunity to say. If you want to refer to a length, you could say the number, or you can say the line BA. That also works, but the communication is important. So I'm glad that we ran into that. So the length of BA is? Okay, good. 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 That's the first step. If you can't do that yet, you got to practice that. Next, sine, if you remember, I'm going to write the mnemonic here because I might forget. SOHCAHTOA. Sine uses opposite over hypotenuse. What's opposite? 3. What's hypotenuse? 5. So that's why I wrote 3 over 5. So basically what I'm saying is if angle A is a certain way, it will give me these two lengths as 3 and 5, or a ratio of 3 to 5. Let's try cosine. Cosine, if I use a mnemonic, creates a fraction with adjacent and hypotenuse. So what's my fraction? Say, you with me? What's my A? Yeah. So the 4 goes on top. Let me put it this way. Cosine is adjacent over hypotenuse. So you just match the numbers. A is 4, H is. So cosine of A, whatever that angle is going to equal 4 over 5. You plug that into calculator, it's going to equal 0.8, whatever. Tangent. So you want to try again? What letters am I going to use for the fraction of tangent? For the ratio? Look at the mnemonic, or say it to yourself, SOHCAHTOA. Okay, so I'm going to walk you through it. For SOHCAHTOA, which one of these three words uses the letter T? So if this is what I'm doing, what two sides will I create a fraction with? O and A. And then you just find the numbers. That happens to be a 3. And A happens to be a 4. There it is. Let's do it one more time. This time, take a look. I am working with, I'll use red, B, angle B, angle B. Which angle am I interested in right now? Angle B. If I'm working with angle B, a lot of these disappear. I need to reset it. With respect to angle B, what is my hypotenuse? With respect to angle B, which side is my opposite? With respect to angle B, which side is my adjacent? A brave soul. Other than Cameron, he's too brave. He's already given me something. Leanne? The 3 will be adjacent, correct? Not so. Look at the 90 degrees. Where's the 90? It's right here, right? That means the 5 is the hypotenuse. Good try though, okay? Make mistakes, take risks, that's good. So this is A, that's O, and that's H, which means my sign, remember, it's SOHCAHTOA. Write it out. Sine uses the letters O and H. Sine is a relationship of opposite over hypotenuse. It's 4 over 5. Sine of angle B will always give me a ratio 4 over 5. Cosine uses the letters A and H. So cosine of angle B is 3 over 5. And tangent is opposite over adjacent. It's going to be 4 over 5. So I showed you two things. Number one, learn how to set up your OAH, opposite adjacent hypotenuse. What do you think, Micah? What do you think, so okay? Next, if you know O, A, and H, you can set up the correct ratio. If you can set up the correct ratios with fractions like this, we're ready to do some of the math. So let me show you. Number 2 is your first, if you've never done this before, this is going to be your first question with true trigonometry, using angles to find sides and vice versa. Here we go. Choose the correct primary trig ratio to solve the unknown variable. So I'm looking for this letter right here. Write out the trig equation and then solve. Okay. Step 1, we have a right angle triangle. We can use SOHCAHTOA. What angle are we given? This is going to be my theta, okay? With respect to 37, which side is my hypotenuse? Which side is my opposite? And which side is my adjacent? Yes. Sorry, I can barely hear. Let's go one by one. What would you? Yes, yes, it is. This part, yeah, yeah. Perfect. Okay, 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 great, great, great. Amazing. Perfect step one. What ratio are we going to use? Now, you have to think about this. What side do I have right now? I have A. What side do I want? I want O. Do you see where I'm going with this? Are you trying to answer? Do you know what I'm going to ask next? What ratio am I going to use? Why do you say that? Right. Tangent, using the mnemonic SOHCAHTOA, between so, ka, and toa, which one's going to use O and A? Toa, right? So tangent is what we're going to use. So let's set it up. Tangent of my angle, so tangent of my angle, 37 degrees, equals opposite over adjacent, which is the same as saying x over 10. Every day there's new COVID cases in Northern. What's going on? Ready? So tangent of the angle 37 will give me a relationship between the far side and the bottom side. Well, I don't know what tan 37 is. That's where the calculator comes in. Take your calculator and type in tan 37. And if you did it correctly, and if the calculator is cooperating with you, you should get approximately 0.75 rounded. If you do not, please raise your hand. You may have a different setting on and we need to change that setting. Did anyone get anything other than 0.75? Yeah? No, pardon me? How did I get the? I actually plugged this part into the calculator. That's the only way we can do that. And the reason why I ask you about the calculator is because calculators have lots and lots of different algorithms placed in. Calculators can do angles based on degree. So you'll see the letter D or DEG on it. Some calculators can also do angles based on radians. So you might see the letter R or RAD on it. I need degrees. We've been using degrees all this time. Please do not use radians. We're using nothing but degrees. Anyone here getting anything other than 0.75? Yep, perfect. So right now, look at the screen set as RA on test 3. Now the reads on type 10 of 35. Yes, 37. Okay. So everyone, if you mess up, like it is sort of your responsibility to know how to change the settings of your calculator. So make sure it's always in degrees. If not, come and ask me so that I can teach you how. All right. Next bit. Next bit. How do I get X all alone? That's my goal. Yep. Not add a 10. Yeah, you bring it to the other side, but here's the problem. Me as a mathematician, I get a little antsy when students or other mathematicians or whoever say bring it to the other side. It's not magic. How do you get rid of a division of 10? Yes, you multiply both sides by the 10. So division of 10 and a multiplication of 10 will turn into a 1. leaving the right side as 1x. And 0.75 times 10 is going to be approximately 7.5. So that's wild. If you have an angle and you have one side, you can figure out other lengths. Do you understand the implications, the application of this? I'll do it one more time with example B, but it's going to be crazy if you see the applications of this. All right? I'd like to move on, but any questions so far? You're going to see it one more time. Yes. Pardon? 0.75 become this? Okay. All right, next one. I'm going to do blue. Okay, so here it is. I have an angle. It's a right angle triangle. I'm looking for a side. Step one is OAH. Go ahead and label it. This time I'll give you 10 seconds. If you did it correctly, the furthest side from the square is my hypotenuse. The side furthest away from the angle of interest is my opposite. And the last section that I didn't touch yet is my adjacent. Next. Yes. Well, I'm not sure. I'm not sure exactly what part is confusing. So I'll go through my train of thought. I always identify the 90. So I know this is going to be my hypotenuse. Okay. I also know this is the angle that I'm going to use. That's the only angle they give me right now. And so the furthest side away from that is always called the opposite. And then I don't even think about the adjacent. Carter likes to do it that way. But for me, I label those two. And then the third side must always be adjacent, that by default. Okay. Yes. Yeah, sure. So next, I want to find B. I have this angle. Which ratio will help me? Which ratio uses the pieces that are here? Yep. The COS? Yeah, the cosine. Yeah, you're right. Oh, wait. Cosine or sine? Well, again, they give me no information about A. Which side do they give me? They give me O. Which side do I want? I want H. So look at SOHCAHTOA. Which of these three ratios use O and H? So, yeah. So I'm going to set it up. Sine of 55 degrees equals opposite over hypotenuse. Yes. All right, so now we want to find B. So here it is. Let's simplify this. Right now, sine 55, you could leave it as is, but I feel like people might be less anxious if we get rid of sine 55. Let's calculate it. In your calculators, figure out what sine 55 equals. And if you did it right, You should get 0 point, someone tell me. Yeah, rounded, 819, so it's 82. 0.82. Now I want B all alone. So here's a little bit of algebra. You might think, oh, can't I just multiply both sides by 4.1 just like we did here? Not really. What's being divided right now? It's B. Let's get rid of that fraction so we feel more comfortable. Multiply both sides by B, and you get yourself 0.82B is equal to 4.1. What is going on? What's that? And then, how do I get B all alone? We can divide both sides by 0.82 because right now there's a multiplication. So B equals and we can solve that in the calculator. Which is? Yeah. So this unknown side was just a 5. Welcome. You made it. So let me try to explain to you the implications of this. The implication is, if we have a distance from one point to another, and if we can use whatever technology to measure an angle, you can figure out lengths of seemingly unreachable locations. Here's a simple application. If I told you, hey, how high is this ceiling? How high is this wall? Define that. How? I make an imaginary triangle. Can you imagine a triangle right now? Okay, let's go this way. How high is this wall? That's my challenge to you. If you can figure that out, I'll drop $100. Pizza lunch, whatever. Let's say I did that, right? What you would do is create an imaginary triangle. See this imaginary triangle in your head? Yeah? And you take a meter stick and just measure it. So you get yourself one length, just like we did here. And then you take a protractor, literally, and just eyeball an angle. You can find measurements and do math with areas that are seemingly out of your reach, limited to the human body. That's trig. Think about it on a grander scale. Forget the height of a building. What if someone challenged you? What's the height of the CN Tower? Can you do it? Well, not with your hands, because you can't climb all that, right? What are you going to do? Take a meter, like a measuring tape that long and go all the way up on a helicopter? What are you going to do? But no, the math don't lie. And so what we could do is try to accurately measure the angle that you have to tilt up to the tip of the CN Tower, and just figure out how many meters you walk away from the base of that. You can calculate things that are out of your reach. The implications of something like that is crazy. Because you might be thinking, well, what about real life things? Have you ever seen those people in, you know, those very fluorescent like construction vests, right? And they have this tripod. There's a bunch of sort of you know, older gentlemen that's like looking through the tripod like this, and then they look, and then they look, and they look, and like, you've seen that before, yes? They're using that machine to accurately measure levels as well as angles. They're doing trig. They're doing trig. They're using angles and they're using a machine to accurately measure the angle to the t, right? To the point whatever degrees. But once they're able to do that, they can calculate random distances across blocks on blocks on blocks. Why? Well, they have to measure. Let's say they're setting down a pipe. Let's say they need to figure out how much money they need to, or how much cement they need for whatever. Again, the applications of this is really endless. As simple as it is, it's so effective and very, very powerful. And so I'm not going to get you to do the second part just yet. I would like you to I'll clear this. Yeah, hands up. How many feel like they're doing this for the first time? Okay, then you know what? Let's take it slow. That's fine. So number 3, circle number 3. Do not do number 4 because you haven't learned that yet. And I would love for you to figure it out yourself, but I'm not gonna. Okay. Let's see. Don't do number 4. Don't do number 5 because I have to teach you how to get angles from sides, not the other way around. And from here, I think you'll be able to do number 6, B, and D. Okay. So your homework. From the handout, from the homework, from the sheet, do numbers 3, do number 6, and I want you to do a little bit more to make sure you can find side lengths. I need you to do a little bit more. I need you to be so good at this, because it will stay with you for a very long time. All unknown sides. Wow. And also, please write this down. Textbook page 292. Number 3, A, C, just A and C. Yeah. Okay. Number 3 from the sheet, number 6 from the sheet, and from the textbook, number 3, A, and C. I'm taking this super slow because, again, some of you might be seeing this for the first time. Others might need that refresher to feel confident going in. There are, I'll say it right now, for 90-degree triangles, there's maybe 2 more layers on top of this. So make sure you get this down pat, you feel confident. I'll show you the next layer on Monday. And then the final layer on Tuesday. And then we're gonna pick up some speed. So please prepare, don't just relax over the weekend. You have to practice this. It's one of the very few occasions where I'm really pushing for it. And I will now give back your Angry Bird stuff.